Today we're going to look at solving systems of equations by graphing. So first let's look at why we need to learn this. You can compare costs, for example, by graphing a system of linear equations. So here is two different bowling alleys and how much they charge, and we can use this to figure out when the charges or when the costs would be the same and at what times they would be cheaper to go to one bowling alley or the other. So Bowl-O-Rama charges $2.50 per game plus $2 for shoe rental, while Bowling Pins charges $2 per game plus $4 for shoe rental. So a system of linear equations is a set of two or more linear equations containing two or more variables. So basically it's when you're graphing at least two lines. A solution of the system on linear equations with two variables is an ordered pair that satisfies each equation in the system. So what that is saying is that the solution is where the lines cross. So you graph the two lines and look for where they cross or where they share, and that is the solution. So on this particular scenario, we have, this is the two equations that we would use. This one would be Bowl-O-Rama, $2.50 per game, $2 for shoes. And the other one would be Bowling Pins, $2 per game, $4 per shoe. So we have a y-intercept and we have a slope. So I'm going to just go ahead and show you what these look like graphed, because we've already talked about how to graph them. If you notice, these two lines are very close together, but they intersect right here. So what does this tell us? So we have the cost per game. So this down here would be the number of games that you bowl, number of games. This one over here would be the cost. So this tells us that if you were to bowl 4 games, the cost would be the same at $12. 4 games for both of them would be $12. If you bowl less than 4 games, then this one would be your best bet, and that one was the y-intercept of 2, which is this one. It'd be cheaper to go there. If you intend to bowl more than 4 games, then that would be the other line, and you would want to go to the other bowling alley. So this is how we use this. So now let's learn how to do it. First of all, let's say that we think we know the answer. So we're just going to show you how you can check your solution to see if it is correct. So we have two linear equations here. To graph them, it would be easy to put them into slope-intercept form, graph them, and then see if they do indeed cross at 4, 1, or we can do it mathematically without having to graph. To do it mathematically, we're going to take both equations. Since 4, 1 is our ordered pair, that means x is equal to 4 and y is equal to 1, and we're just going to plug those numbers into the equations and see if the equations would be true. So the first one, that would be, if we plug in 4 for x, that would be 4 plus 2 times 1, because we're plugging in 1 for y, equals 6. And we're just going to solve this and see if it's a true statement. Of course, 2 times 1 is 2. 4 plus 2 is 6, so that checks. That says, yes, that could be a solution there, but it has to be true for both of them. So now we're going to take the same numbers, 4 and 1, and we're going to plug them into the second equation. So that would be 4 minus 1 equals 3. Is that a true statement? It is. Since both of these are true, then when we graph these, they indeed are going to cross at 4, 1. So you can check to see if your solution is correct by plugging in the numbers to both equations and seeing if they are true. So again, here we have two equations. We're going to say, do they cross at -1, 2? We could graph them and see if that's where they are, or we can check mathematically. So let's plug in the numbers. For the first equation, we're going to plug in -1 to x right here. We're going to plug in 2 to y right here. Here's our equation. we follow our order of operations and do multiplication first. That would be -2 plus 10 equals 8. Is that true? 8 is equal to 8. So yes, it checks for that line. Let's check it for the second line, which is right here. We plugged in -1 for x and 2 for y. 3 times -1 is -3. And then -4, so -3 minus 4 would actually be a -7. So that one does not check out because this is not a true statement. It's not equal to. It has to satisfy both equations in order for it to be true. So let's look here. If we were to graph this, you would see that it crosses right here, and that's not -1, 2. So you can determine that mathematically by plugging in numbers. Same thing here. So if we plug in the numbers, it would be 2 times 1 plus 3. That's 2 plus 3 equals 5. So that does check. If we plug in the order pair 1, 3 to the second equation, it would be -2 times 1 plus 3. And -2 times 1 is -2. Plus a +3 is 1. They both check out. So yes, when you graph them, they do indeed cross at 1, 3. One more example like that. We plug in the numbers. 2 minus 2 times -1 equals 4. Order of operations, we do our multiplication first. That would be 2 plus 2 equals 4. That checks. We plug them into the second equation. 3 times 2 is 6. 6 plus 1, -1 is not equal to 6. So that does not work out for that line. So that is not the solution. The solution is actually at, it looks like 2, 1, not 2, -1. Okay, so that's how you check them. Now let's see how we would solve it by graphing. In other words, we're going to graph these two lines. We're going to see where they cross, and that is the solution, and then we're going to check to see if that solution is correct. These two equations are already in slope-intercept form. We always start with our y-intercept. So our y-intercept is -1. Our slope is 1 over 1. So we go to -3 and we do a slope of 1 to 1, up 1 over 1. There's the line. The other one has a y-intercept of -1. This time the slope is a -1, 1. So it would graph like this. Now when you graph, you're going to have to use a straight edge because if you do not, you have to be very accurate when drawing these lines in order to solve by graphing. So sometimes it actually helps to do what I call repeated slopes. For example, on the first line, here was the y-intercept. We went up 1 over 1, up 1 over 1. And to do, see my line's not exactly on because it's hard to do with a PowerPoint. It's a little bit off there. But that gives you a guide in order to make a very straight line. And then you look to see where they cross. It looks like they cross. So it looks like they cross at 1, -2. 1, -2. Now to make sure, we would need to plug those numbers, the 1, -2, back into both equations like we just practiced to see if they check. And if we plug it into the first one, y is equal to -2 equals x was 1 minus 3. -2 is equal to -2, so that checks. We try the other equation and we plug in y is -2 equals the opposite of 1, so that's -1 minus 1, and that checks out as well. Check, check. So that indeed is the solution. So with graphing, if you're not sure, it's always good to check to make sure mathematically that you have the right solution. Okay, the first line here is not put in slope-intercept form, so we're going to move the x term over here so that it will be in slope-intercept form. So that would be y equals a -x plus 3. Now we can graph that with a y-intercept of 3 and a slope of down 1 to the right 1. The other one is already in slope-intercept form. So we start with our y-intercept of 1, and we go down 1 to the right 2. And when we graph, it looks like this. And it looks like visually that they cross at 4, -1. But we want to check that. to make sure that that is correct. Is 4, -1 actually the solution? Let's plug it in and see. In the first equation, x, which is 4, plus y, which is -1, is equal to 3. And indeed, that is true, so that checks. The second equation, y, which is -1, is equal to -1/2 times x, which is 4, plus 1. We do our multiplication first. -1 is equal to -2 plus 1. There's -1 is equal to -1. It checks as well. So that is our solution. We graphed it and we checked it. Okay, both of these are already in slope-intercept form. So with the first line, we have a y-intercept of -1, and then we have a slope of down 2 to the right, 1, graphs like this. The second one, we have a y-intercept of 5, and then a slope of 1 over 1. So we go to 5 on the y-axis, up 1 over 1, and it looks like this. It looks like it graphs or crosses at -2, 3. So if we were to check -2, 3, we would see that indeed it checks. Okay, another example. First one's in slope-intercept form. Our y-intercept is -3. Our slope is up 1 to the right 3, so it's graphs like this. The second one is not in slope-intercept form. We have to move the x term, which is going to be the slope right here. We tell the 4 to scoot over, and that would be a -2x. So our y-intercept is 4, down 2, over 1. It graphs like this. It looks like they cross at 3, -2, and when we check it, they check out. Now let's look at this. Video Club A charges $10 for membership and $3 per movie rental. Video B charges $15 for membership and $2 per movie rental. For how many movie rentals will the cost be the same at both video clubs? What is the cost? So first we have to write an equation for both the places. First we have Video Club A charges $10 for membership and $3 per movie. How do we write that as an equation? We would write it as 3x plus 10. For the second one, Video B charges $15 for membership and $2 per movie. That tells us our slope. So here's our two equations. If we were to graph both of these using our y-intercept and our slope, we would see that they cross at 525. So that means the 5, or the x, was represented by the number of movies, and the y was represented by the cost. So that means the cost will be the same for 5 movies that cost $25. You can always look at the way your axes are labeled. This would have been labeled number of movies, and this axis would have been labeled cost. And so you know that at 5 movies they cost the same. Now where would it be more expensive and less expensive? Well, if you wanted to rent less than 5 movies, you would want to go with the one with the y-intercept of 10, which is this one. If you were going to rent more than 5 movies, you would want to go, this line here is less, so you would go with this one, which was the one that had a membership of $15. So not only does it tell you where they are the same, but you can also tell, based on the number of movies that you're going to rent, which is my better deal. And we all like to have better deals. So this has been solving systems of linear equations by graphing. Remember that the solution is where the two lines crossed. So the solution is an ordered pair. Good luck.